Saturn's rings should be untouched for billions of years. Nothing about them should change in a human lifetime. Old Voyager data and quiet Cassini readings, gathered for other reasons, lined up in a way nobody planned. Nobody was looking for this. What they found changes everything. Why everyone assumed the rings were permanent. For most of the last 2 centuries, scientists treated Saturn's rings the same way they treated Saturn itself, as something ancient and unchanging. The assumption made sense on the surface. The rings stretch more than 170,000 miles across, built from countless chunks of ice, ranging from tiny dust grains to pieces the size of a house. A structure that big, orbiting a planet that massive, seemed built to last as long as the solar system itself, roughly 4.5 billion years. Early telescope observations going back to the 1600s only reinforced the idea, since the rings looked exactly the same from one century to the next through any instrument available at the time. Nobody had a strong reason to think otherwise, since nothing about the rings looked like it was actively falling apart from a distance. And no telescope on Earth was powerful enough to catch a slow process happening in the space between Saturn and its rings. That assumption held for decades, right up until a spacecraft flying past Saturn on its way to the outer solar system noticed something in the data that did not fit the picture at all. The strange pattern Voyager left behind. When Voyager 1 and Voyager 2 flew past Saturn in 1980 and 1981, they were not hunting for proof that the rings were dying. They were there to take pictures and study the planet's atmosphere, magnetic field, and moons during a brief flyby that lasted only days. But buried in their instrument readings were odd, bright and dark bands near Saturn's equator, patterns that did not match anything scientists had prepared for. The bands sat at very specific latitudes, not spread randomly across the planet, which told researchers the cause had to be something structured and repeating rather than random weather in Saturn's atmosphere. In 1986, NASA researcher Jack Connerny proposed an explanation that sounded strange at the time. He suggested that electrically charged particles from the rings were being pulled along Saturn's magnetic field lines and dumped straight into the atmosphere, creating those exact bands. It was a theory built on a handful of readings and a hunch. For years, it stayed just that, an idea nobody could confirm from a single flyby decades earlier, since Voyager was already speeding away toward Uranus and Neptune and could not turn around for another look. Confirming Connerny's idea meant somebody needed to sit and study Saturn for hours at a time, and that would not happen until a much bigger telescope pointed straight at the planet almost 30 years later. The Keck Observatory study that proved it. In 2011, physicist James O'Donoghue and his team pointed the Keck Observatory in Hawaii at Saturn and recorded infrared images of its upper atmosphere for several hours. Infrared light let the team see heat patterns invisible to a normal camera. And those patterns lined up almost perfectly with the bands Voyager had picked up decades earlier. They found the same bright and dark bands Voyager had hinted at, and this time, they had enough data to explain what was causing them. Ice particles from the rings, charged by sunlight and by plasma from tiny meteoroid impacts, were traveling down Saturn's magnetic field lines and slamming into the atmosphere at specific latitudes, exactly where invisible field lines connect the rings to the planet. The brightest bands matched the spots where the field lines from the rings met the atmosphere most directly, essentially drawing a map of where the rain was landing. The team published the full results in the journal Icarus in December 2018, naming the process Ring Rain. The name was not just poetic, it described almost exactly what was happening: water ice literally raining out of the sky and onto the planet below. Before we move on, if you're enjoying this analysis, please consider subscribing. It helps the channel tremendously. Naming the process and explaining the mechanism was one thing. Figuring out how much material Saturn was actually losing every second turned out to be a much bigger shock. How ring rain actually works. The physics behind ring rain breaks down into a simple chain of events. Ultraviolet light from the sun, along with plasma clouds thrown off by tiny meteoroid strikes, gives a static charge to the smallest ice particles in the rings, particles often smaller than a single strand of hair. Once those particles carry a charge, Saturn's magnetic field grabs them and pulls them along field lines toward the planet, the same way a magnet pulls iron filings across a table. The particles do not fall straight down. They spiral along curved field lines for thousands of miles before finally reaching the atmosphere, which is part of why the resulting bands sit at such precise latitudes rather than spreading evenly across the whole planet. When the charged ice reaches the upper atmosphere, it burns up and vaporizes, turning into water that glows faintly under infrared light. Connerny, the scientist who first proposed the idea back in 1986, later compared it directly to weather on Earth, describing it as rain falling from the sky just like it does here, only made of ring material instead of water clouds. The difference is the scale and the invisibility. This rain cannot be seen with the naked eye, and it never stops. It runs every hour of every day, quietly draining the rings from the inside out. Once scientists understood the mechanism, the next question became obvious. How fast was this actually happening, and how long could the rings possibly survive it? The numbers that shocked scientists. The answer stunned even the researchers who found it. The rate of ring rain works out to roughly 2 tons of water per second, enough to fill an Olympic-sized swimming pool in about half an hour. Stretched across a full day, that adds up to an amount of water that would be difficult for most people to picture. Drained continuously from a ring system that already looked paper thin compared to the size of the planet it surrounds. O'Donoghue did not hide how strange that felt to calculate, saying the rings are literally raining water onto the planet, and that ring systems are temporary features, not built to last. Based on ring rain alone, the study estimated the entire ring system would be gone within roughly 300 million years. That sounds like an enormous stretch of time by human standards. Compared to Saturn's age of over 4 billion years, it is closer to the final seconds of a much longer story. A bit like a person living to 90 years old and only wearing their favorite jacket for the final 3 weeks of that life. 300 million years already sounded fast for something people assumed was permanent. What NASA found next made that number look almost optimistic. Cassini's final dive makes the problem worse. Before Cassini deliberately plunged into Saturn in 2017, ending 13 years in orbit, it flew through the gap between the planet and its innermost rings 22 separate times in a sequence NASA called the grand finale. Those close passes let Cassini fly closer to Saturn than any spacecraft ever had, threading a gap only a few thousand miles wide between the cloud tops and the inner rings. During those close passes, Cassini directly measured ring material falling into Saturn's equator, material that ground telescopes alone could never have detected from millions of miles away. Combined, the different loss channels add up to roughly 10,000 kilograms of ring material falling into Saturn's atmosphere every second. Adding that equatorial infall on top of the ring rain measurement changed the entire timeline. The rings now have less than 100 million years left, not 300 million. O'Donoghue put it plainly, calling that span relatively short compared to Saturn's age of over 4 billion years. Losing 2/3 of the original estimate was bad enough on its own. But a second Cassini finding unrelated to ring rain made the situation even stranger. The age mystery Cassini uncovered. During those same grand finale orbits, a team led by Luciano Es at Sapienza University in Rome used Cassini to measure the gravitational pull of the rings directly, separating their mass from Saturn's own mass for the first time in the history of the mission. The team published its findings in the journal Science in January 2019, and the ring mass came back far lower than anyone expected going in. Saturn's rings are unusually clean, made up of more than 95% water ice, with very little of the dark interplanetary dust that should have built up over hundreds of millions of years of space debris hitting them. A ring system that old should look dirty by now, coated in dark material the same way an old car windshield collects grime over years of driving. This one does not. Based on the low mass and the clean ice, the team calculated the rings are likely only 10 to 100 million years old. NASA's own release on the study said plainly that if the rings really are that young, they may have formed during the age of dinosaurs on Earth, meaning Tyrannosaurus rex walked the planet before Saturn ever grew the rings people photograph today. A ring system that young, disappearing that fast, meant the rings were never a fixed feature of Saturn at all. They were something closer to a passing event that happened to include human beings watching from Earth. Why this changes the story of Saturn. Put both findings side by side and the picture shifts completely. The rings likely formed somewhere between 10 and 400 million years ago, possibly from a shattered moon or comet that wandered too close to Saturn and got torn apart by its gravity into countless icy fragments. They are actively losing mass right now through ring rain and equatorial infall, at a combined pace that leaves them somewhere under 100 million years of life remaining. Henry Throop, a senior scientist at the Planetary Science Institute who was not part of the ring rain study, summed up how much this overturned old thinking. He explained that scientists used to think the ring system was fixed and would always look the same, but now it is clear the rings are a dynamic place, changing on a year-to-year basis, shifting in ways nobody could have measured before spacecraft like Cassini existed. Saturn itself is expected to keep existing for billions more years after the rings are long gone, orbiting the sun as a bare gas giant the way most of the other planets already do, stripped down to just its clouds, its moons, and its magnetic field. Knowing the rings are temporary changes how people should look at every photograph ever taken of Saturn. It also raises an uncomfortable question about timing that most people never stop to consider. The timing. Nobody expected to be this lucky if the rings formed only tens of millions of years ago and will vanish within the next 100 million years. That means humanity exists inside a narrow window of Saturn's multi-billion year lifespan, when the rings even exist at all. Dinosaurs never saw them. Whatever comes after humanity on Earth may never see them either. Every image taken by every telescope, every space probe, every photo in every science textbook happens to fall inside a sliver of time that is short even by the standards of a single planet's history. Scale Saturn's full lifespan down to a single calendar year, and the rings occupy only the last few hours before midnight on December 31st. With humanity's entire existence squeezed into an even smaller sliver inside that same window. That is not a coincidence anyone planned. It is simply where the numbers landed once scientists finally sat down and measured them properly. Saturn is not done revealing its secrets yet, and the same rings currently raining into its atmosphere are still being watched more closely than ever before. What comes next? Ground telescopes and space observatories continue tracking the rings today, watching for any change in the rate of ring rain or the density of the equatorial infall Cassini first detected. In March 2025, Saturn's rings briefly appeared to vanish from view entirely, an unrelated effect caused by the planet's tilt lining the rings up edge on with Earth. The rings did not actually disappear that day, but the timing served as a reminder of just how thin and fragile they really are. A structure only a few hundred meters thick stretched across more than 170,000 miles of space. Every measurement scientists take now adds detail to a countdown that started long before humans existed and will finish long after most of what exists today is gone. Saturn will keep its rings for a while longer, but not forever. And every study confirms the same conclusion. The rings people have watched their entire lives are already disappearing, one invisible drop of ice at a time. If you enjoyed this video, make sure to subscribe, and I'll see you in the next video.